Hello everyone, welcome back to Sulekha physics classes. It is the most easiest way to learn all the concept of physics through this class. Today I am going to start one short revision of chapter 8, that is electromagnetic waves. As the name suggests, electromagnetic waves, it means both electric and magnetic field are present to produce electromagnetic waves. So whatever you have studied up to chapter 7 about electric and magnetic field and related equations, all those equations are used to explain electromagnetic waves, right? For this year, one topic is deleted from this chapter, that is displacement current. But I will discuss that displacement current also because it is used when we discuss about electromagnetic waves, right? So let us start quick revision of this chapter, electromagnetic waves. First, I will discuss about basic idea of displacement current. There is a new type of current. Now, you know current flows through a wire, that is called conduction current. But what do you mean by this displacement current? Okay. One question is there. You know, according to Faraday's law, a varying magnetic field produces electric field. You know, whenever there is a magnetic flux linked with the coil changes, an EMF is induced and current is produced in the coil. It means electric field is produced, right? So a varying magnetic field produces electric field according to Faraday's law. But is converse true? It means is it possible to produce electric field with the help of magnetic field? Yes. Who proposed this idea? It was proposed by Maxwell, that time varying electric field also produces magnetic field. He gave this idea that nature loves symmetry. If a time varying magnetic field produces electric field, then a time varying electric field also produces magnetic field. And he proved this with the help of some experiment also. Okay, so how he proved this one? So first he used this Ampere Circuiter Law. You know what do you mean by Ampere Circuital Law? Closed integral of this B dot dl equal to mu naught I inside. I is the current which flows through this closed loop, right? But Maxwell shows that this equation, Ampere Circuital Law, is inconsistent when applied to charging or discharging of a capacitor. Inconsistent means it's not current when it is applied to charging or discharging of a capacitor. Suppose this is one circuit, battery is connected, key is connected, and I have taken two closed surface, S1 which is outside the plates and S2 which is in between the two plates, right? Now Ampere Circuital Law for this loop S1 is what? B dot dl mu naught I, because I current flows through the circuit when battery is connected, right? Now for loop S2, you know, in between the plates no current is flowing, so B dot dl becomes 0 for this loop S2, right? It means B is 0. This is according to Ampere Circuital Law. But if you place one needle in between the plates, the needle shows some deflection. It means for this case, what happens? This Ampere Circuital Law is not true. It is inconsistent in this situation. Why? Because when you put one needle in between the plates, the needle shows some deflection. It means some magnetic field is present. But according to Ampere Circuital Law, in between the plates, magnetic field is what? 0. So, which type of magnetic field is present? From where that magnetic field arises? You know, magnetic field is only produced due to a change in current or due to magnet. So, here there is no current in between the plates. So, how that magnetic field is present, right? So, Ampere Circuital Law is inconsistent in this situation, and this led to the concept of displacement current. From here, displacement current comes. Maxwell explained this displacement current by modifying this Ampere Circuital Law. So, according to Maxwell, what happens during charging or discharging of the capacitor? Suppose capacitor is discharging when we use this battery in this circuit. Capacitor plates start what? Charging, na? And this end becomes positive during charging and this end becomes negative. It means when the capacitor is fully charged, there exists electric field between these two plates, and due to that varying electric field, current is produced in between the plates, and due to that current, magnetic field is produced and needle starts deflecting. It means the current which is produced in between these plates due to this varying electric field is called displacement current, right? So I have written here, according to Maxwell, during charging or discharging of capacitor, varying electric field is produced due to which what? Current flows in between these plates, and that current is called displacement current. So displacement current is produced due to a varying electric field or electric flux. Here this current is called conduction current, which flows in between the circuit or through the wire, right? Conduction current IC. And the current which is produced in between the plates due to varying electric field, that current is called displacement current. So please take a screenshot of this one, then I will discuss displacement current. Okay, hope you have written these things. What we have discussed, that a varying magnetic field produces electric field according to Faraday's law, and then according to Maxwell, reverse is also true. A time varying electric field also produces magnetic field with the help of which current? Displacement current, right? Okay, I am going to rub this one. Now, what is the expression for that displacement current, right? Displacement current, this IC is nothing but induction current. It is produced due to flow of charge, motion of charge, right? And induction current ID. This one is, sorry, displacement current ID. ID is what? Displacement current. And it is produced due to time varying electric field. Due to change in electric field, this current is produced, right? What is the expression for this current? ID. ID is equal to, it is produced due to a change in electric field. So, or you can say electric flux, and its magnitude is equal to ID equal epsilon naught d phi E by dt. Phi is electric flux. And in terms of electric field also, phi is what? E dot A. So you can write epsilon naught D. Phi is what? E dot A, EA by dt. You take E outside, A outside. So epsilon naught A is area of the plates. It's constant. dE by dt. This is the expression for displacement current ID in terms of change in electric field, or also you can write in terms of change in electric flux, right? This is the expression for displacement current. So from here, it is proved that a varying electric field produces magnetic field, and a varying magnetic field produces electric field, and due to these concepts, electromagnetic waves are produced, right? And after discovery of this displacement current, Maxwell modified Ampere Circuital Law. Now, modified Ampere's Circuital Law becomes what? B dot dl is equal to mu naught, not only induction current IC but also due to displacement current ID, right? So Ampere Circuital Law is modified by Maxwell. B dot dl equal to mu naught IC plus ID, or you can write B dot dl equal to mu naught IC plus, what is this displacement current ID? You can write in terms of electric flux or also in terms of electric field. Epsilon naught d phi E by dt. This displacement current is produced due to a change in electric flux. So this is about displacement current. Just you must know what do you mean by displacement current, because it helps when we discuss about electromagnetic waves. Okay, so please take a screenshot of this one. After this, we will discuss Maxwell's equation. Now, Maxwell's equation. These 4 Maxwell's equations are in your syllabus. You just revise these 4 equations, right? So, Maxwell formulated the basic laws of electricity and magnetism in the form of 4 fundamental equations. That is called Maxwell's equation. And with the help of these 4 Maxwell's equations, he predicted the existence of electromagnetic waves, right? What are those 4 Maxwell's equations? Okay, first one is Gauss law of electrostatics. Maxwell first equation is about Gauss law of electrostatics. You know what is Gauss law of electrostatics? Surface integral of this E dot ds equal to Q by epsilon naught. From this equation, it is clear that electric field is only produced due to this charge, right? Okay, now this Maxwell's second equation, this is about Gauss law of magnetism. B dot ds equal to 0. From this equation, it is clear that magnetic monopole does not exist, right? Magnetic field are always closed curve. From this equation, it is clear. B dot ds equal to 0. First one is E dot ds equal to Q by epsilon naught. Next one is Maxwell's third equation. It is again Faraday's law of electromagnetic induction. What is that one? That EMF induced is equal to minus d phi by dt. And you know, EMF is, you can write in this way, E dot ds surface integral. From this equation, it is clear that electric field is produced due to a change in magnetic flux, right? A time varying magnetic field produces electric field. This is Maxwell's third equation about Faraday's law. Now after that, Maxwell's fourth equation, Maxwell modified Ampere Circuital Law and finally came to the conclusion that this is about Ampere Maxwell Circuital Law. B dot dl equal to not only mu naught I but mu naught IC plus ID. IC is what? Conduction current, which is produced due to flow of charge. ID is what? Displacement current, which is produced due to change in electric field, right? So you can write in this way, B dot dl equal to mu naught IC plus epsilon naught d phi E by dt, and phi E you can write in terms of electric field also. Phi is what? E dot A. From here it's clear that this magnetic field is produced due to a time varying electric field. So from these four equations, he predicted the existence of electromagnetic waves, that charge is a source of electric field, magnetic monopole does not exist, magnetic field lines are always closed curves, right? Here electric field is produced due to a time varying magnetic field and magnetic field is produced due to a time varying electric field. Okay, so please take a screenshot of this one. After that we will discuss electromagnetic waves. Now Maxwell's prediction of electromagnetic waves. After basic idea of displacement current and Maxwell's four equations which combines all laws of electricity and magnetism, Maxwell found that a time varying magnetic field is a source of changing electric field according to Faraday's law, and a time varying electric field is a source of changing magnetic field, which is Ampere Maxwell Circuital Law, right? It means a change in one field produces another field, and Maxwell showed that these variations in electric and magnetic field both occur in mutually perpendicular directions and have a wave-like properties. Hence, that wave in which both electric and magnetic fields are oscillating perpendicular to each other and have a wave-like structure are called electromagnetic waves. In this way, Maxwell came to the conclusion that electromagnetic waves are produced due to mutually perpendicular variations of electric and magnetic field. So, how these electromagnetic wave is produced? You know, a stationary charge produces only electric field, and charges in uniform motion produces both electric and magnetic field. But how varying electric and magnetic field is produced? That is produced by accelerated charges, and hence accelerated charges is a source of electromagnetic waves. Accelerated charges radiate electromagnetic waves. You must remember these 3 points. A stationary charge produces only electric field. Charges in uniform motion produce both electric and magnetic field. Accelerated charges radiate electromagnetic waves. Now, how these accelerated charges is responsible for production of electromagnetic waves? Okay, for this, consider oscillating charge particle and let f be the frequency of its oscillation, right? Now, you know the oscillating charge particle produces what? Oscillating charge particle produces oscillating electric field having same frequency as that of the oscillating charge particle, right? And again this oscillating electric field becomes a source of oscillating magnetic field. This process continues. It means oscillating electric field produces oscillating magnetic field, and oscillating magnetic field produces oscillating electric field. In this way, both oscillating electric field and magnetic field acts as a source of each other, and hence an electromagnetic wave propagates. It is produced, it propagates in a direction of perpendicular to the E and B vector, electric field and magnetic field. It means electromagnetic waves propagates in the direction of E cross B. So in this way, electromagnetic wave is produced by the accelerating charge particle, because that accelerating charge particle produces oscillating electric field, and then oscillating electric field produces oscillating magnetic field, and this process so on. Both becomes a source of each other, right? So this is given by Maxwell, and experimentally it was given by Hertz. That is called Hertz experiment. First take a screenshot of this one, then we will discuss Hertz experiment. Now Hertz experiment. You know, Maxwell predicted the existence of electromagnetic waves from theoretical considerations. Maxwell explained theoretically the production of electromagnetic waves, but Hertz experimentally confirm the existence of electromagnetic waves. This is arrangement of Hertz experiment. Hertz experimentally proved the existence of electromagnetic waves. In this experiment, it consists of two metal plates. Suppose one is P, another one is Q, and these two metal plates are connected to a thick wire. One end of the thick wire is connected to two metal spheres S1 and S2, and other end of the thick wire is connected to secondary of this induction coil, and input is applied to the primary of this induction coil. Now at every time, current at the input side changes, and due to mutual induction, which you studied in chapter 6 electromagnetic induction, EMF is induced across the secondary of this induction coil, right? And hence a high potential difference set up across these metal spheres. These metal spheres, high potential difference is set up, and in this way these metal plates gets charged. Due to high potential difference across these metal spheres, there is a gap between these two metal spheres. So high potential difference ionizes the air in these gaps, and what happens? It provides path across these gaps, conducting path, and hence the electrons and ions which are ionized across these gaps starts moving back and forth and produces some spark here, and these spark are nothing but electromagnetic waves which are detected by this detector. In this way, electromagnetic wave is produced experimentally in this Hertz experiment, right? So in this circuit, Hertz uses an oscillatory LC circuit for producing waves having frequency 1 mu equal to 1 by 2 pi under root L by LC. High frequency electromagnetic waves is produced here using this LC circuit, whose frequency is given by mu equal to 1 by 2 pi under root LC. In this way, electromagnetic waves is produced. Now, you can define electromagnetic waves in this way. Electromagnetic waves are those waves in which electric field and magnetic field changes sinusoidally with time, right now, and both are perpendicular to each other as well as perpendicular to direction of propagation of wave, right? This is electromagnetic waves. Now, how you represent these electromagnetic waves? With the help of graph also and with the help of equations also. So I will that one after this. Please take a screenshot of this one first. Now, mathematical and graphical representation of electromagnetic waves. How electromagnetic waves are represented graphically as well as mathematically, it means with the help of equations. You know, first we consider plane electromagnetic waves which is traveling along x-axis. The wave is traveling along x-axis. The electric field oscillates along y-axis and magnetic field along z-axis, right? So, electric field vectors are oscillating along y-axis. So, these are electric field vectors shown by this black marker right now, and this shows electric field vector along y-axis. First, if you consider this half cycle, then field is along, electric field is along y-axis and magnetic field is along z-axis. So, this oscillating electric field produces this oscillating magnetic field, and according to Lenz's law, the direction of field is such that it opposes the causes which produces it. It means this magnetic field, oscillating magnetic field, is produced by this oscillating electric field, so it tries to oppose this direction of electric field. So then again direction of electric field becomes this downward, and then again perpendicular to this one magnetic field. Again this oscillating magnetic field is produced by this oscillating electric field. Then next direction of electric field is opposite to this one, like this one. In this way electric field is oscillating along y-axis, magnetic field is along z-axis, and perpendicular to this E and B, it means E cross B gives direction of electromagnetic waves. It means it is along, if electric field is along y-axis, right now field is along z-axis, then direction of propagation of electromagnetic wave is along x-axis. In this way you represent electromagnetic wave graphically, right? Now in terms of equation, how you write? Electromagnetic wave is along y-axis, and you know this wave is traveling wave. In class 11 you studied about traveling wave, equation of motion along x-axis, along negative x-axis, right now. So electric field is along y-axis, means Ey equal to E naught sine kx minus omega t. This kx minus omega t, here k is propagation constant or wave number, you can say 2 pi by lambda. Lambda is wavelength of one cycle. Omega t, omega represents angular frequency. It is given by 2 pi by t equal to 2 pi nu. So this kx minus omega t represents the wave is propagating along, k represents propagation constant, it means along x-axis and in positive direction. If in place of this negative, it becomes kx plus omega t. This represents the wave is propagating along negative x-axis. You studied in class 11. Okay. Then magnetic field along z-axis is what? B naught sine kx minus omega t. Field is along y-axis, magnetic field is along z-axis, and propagation, this electromagnetic wave is along positive x direction. E naught and B naught are amplitudes of electric and magnetic field, and these are maximum electric field vector and magnetic field vector, and these are related by this equation, E naught by B naught equal to C, where C is speed of light. It means electromagnetic waves travel with speed of light, right? And also here E and B are mutually perpendicular to each other, and electromagnetic wave is perpendicular to this E cross B. It means electromagnetic waves are transverse in nature, right? Again, energy density in an electric field is what? Half epsilon naught E square. This is due to electric field. And energy density in a magnetic field is half B square by mu naught. So total energy density of electromagnetic waves is sum of these energy density due to electric field, energy density in a magnetic field. So this E equal to half epsilon naught E square plus half B square by mu naught. This gives total energy density of electromagnetic waves. So these are equations of electromagnetic waves. You must remember this one, right? And this is graphical representation. After this, there are some properties of electromagnetic waves. Please take a screenshot of this one first. Now, different properties of electromagnetic waves. You know what is electromagnetic waves, how it is produced. We already discussed all these things, right? So number one property of electromagnetic wave is, electromagnetic waves are produced by accelerated charge particle. When the particle accelerates, when the charge particle accelerates, it produces changing electric field, and due to that varying electric field, it produces varying magnetic field. In this way, both become source of each other and electromagnetic waves are produced. Number two, these waves do not require any material medium for propagation. Electromagnetic waves does not require any material medium for their propagation. Then number three, all electromagnetic waves travel in free space with the speed of light. All electromagnetic waves have same speed, and that travel with the speed of light. C equal to 3 into 10 to the power 8 meter per second. You can write in this way also in free space. C equal to 1 by under root mu naught epsilon naught. And if you put these values mu naught and epsilon naught, mu naught is what? Absolute permeability, and epsilon naught is permittivity of free space. So if you put these values, you get speed of electromagnetic wave is equal to speed of light, that is 3 into 10 to the power 8 meter per second. Now speed of electromagnetic wave in any other medium is given by V equal to 1 by under root mu epsilon. Here I have written mu naught epsilon naught because mu naught and epsilon naught is for free space. Here mu and epsilon is what? Mu is magnetic permeability of the medium and epsilon is permittivity of medium. Next, number 5. The direction of oscillations of both electric and magnetic fields are perpendicular to each other, right? Both electric field vectors in this direction, magnetic field is this direction, this is y-axis, z-axis, then direction of propagation of wave is along x-axis. So electric and magnetic fields are perpendicular to each other and both are perpendicular to direction of propagation of wave, so that electromagnetic waves are transverse in nature. All three are mutually perpendicular. Then next, for electromagnetic waves, this is electric and magnetic amplitude of electric field and magnetic field, and this is equal to E naught by B naught equal to C, and you know C equal to 1 by mu naught epsilon naught. You must remember this formula. It is helpful when you are solving some numericals, right? The next one, the electromagnetic waves carry energy. There is one question every year asked for 1 marks. Can electromagnetic waves carry momentum and energy? Yes, electromagnetic waves carry energy and is equally divided between electric field and magnetic field, right? Energy density carried by electric field is what? Half epsilon E square, and energy density associated with magnetic field is half B square by mu naught, and both are equal, right? So electromagnetic waves carry energy and is equally divided between electric field and magnetic field. It means half epsilon naught E square equal to half B square by mu naught. Also, the average density of an electromagnetic wave is what? Sum of energy density by electric field and plus by magnetic field. It means average energy density is equal. Energy density means what? Energy per unit volume, right? So this is equal to half epsilon naught E square plus half B square by mu naught. This is average density of an electromagnetic wave. Then next one, the electromagnetic wave also carry momentum. It also carry momentum when it travels through space, and this momentum P is equal to E by C, where E is total energy, C is the speed of light. Okay. Then next one, electromagnetic waves are not deflected by electric and magnetic field. And one more last property, electromagnetic wave shows properties of reflection, refraction, interference, diffraction, polarization. All these properties are shown by electromagnetic waves. So these are different properties of electromagnetic waves. I have written here 11. You must remember these properties. It may asked in 1 or 2 marks question right now. And also for numerical purpose, you must revise these formulas. V, C, E naught by B naught equal to C, and this one. Okay. I'm going to solve one numerical based on this formula. First, to take a screenshot of this one. Okay. Now I am going to solve one numerical. Question is, the magnetic field in a plane electromagnetic wave is given by By equal to 2 into 10 to the power minus 7 sine 0.5 into 10 to the power 3x plus 1.5 into 10 to the power 11 t, and this is unit Tesla. It means By is given. Now you have to find what is the wavelength and frequency of the wave, and another one, write an expression for electric field. These two things you have to find. So first, By is given. By is given by 2 into 10 to the power minus 7 sine 0.5 into 10 to the power 3x plus 1.5 into 10 to the power 11 t, right? Now you have to compare this By with a standard equation of magnetic field. What is that one? B equal to B naught sine kx plus omega t, right? Now you compare this equation with this one. Here this kx, it means you compare this one, so this is the value of k. K is what? Propagation constant, a wave number, 0.5 into 10 to the power 3, and you know k equal to 2 pi by lambda. From here you can easily find lambda. This is equal to 2 pi by k. 2 pi you can put 3.14 by k is what? 0.5 into 10 to the power 3. When you solve this one, you get wavelength lambda equal to 1.26 into 10 to the power minus 2 meter. In this way, you have to find wavelength. Another one is frequency. So you compare this term. This one is what? Omega t. It means this one is omega, angular frequency. Omega is what? 1.5 into 10 to the power 11. It means omega is what? Omega equal to 2 pi by t, and 1 by t is frequency. It means omega equal to 2 pi nu. Right now, this one is second part, okay, and this one is first part. So you have to find frequency. So nu equal to omega by 2 pi. What is omega here? Omega is 1.5 into 10 to the power 11 by 2 pi, 2 into 3.14. Okay, and when you solve this one, you get the value after solving is 23.9 into 10 to the power 9 Hertz. Hertz is the unit of frequency. In this way, when you compare this equation By with a standard equation of magnetic field, you get the value of wavelength and frequency. Right? Hope you understood. Now, second one is write an expression for electric field. It means E you have to find. E. How you find E? Okay, you know B equal to B naught sine kx plus omega t. It means B naught is also given. This one, na? B naught is given. 2 into 10 to the power minus 7. And you know one relation between E naught and B naught. What is that relation? E naught by B naught equal to c, speed of light. From here, you can easily find E naught equal to B naught into c. B naught is given 2 into 10 to the power minus 7, and c is speed of light 3 into 10 to the power 8 meter per second. After solving this one, you get 60. Its unit is what? Volt per meter. So you get 60 here, E naught, and you know E is what? E naught sine omega t. Or you can write kx plus omega t, anything, right? Kx plus omega t, right? E naught you know, E naught is 60 sine, k you know, k is 0.5 into 10 to the power 3x plus omega, omega is what? 1.5 into 10 to the power 11 t. So you get E. But what is the direction of E here? Okay. Magnetic field B is along y-axis, and here propagation vector is along x-axis. It means magnetic field is along y-axis. In this direction, magnetic field is there, and direction of electromagnetic wave is along x-axis. This is direction of wave. So what is direction of electric field? If B is along this one, x is along this one, and electric field is, direction of electric field is such that it is perpendicular to both magnetic field as well as direction of propagation of electromagnetic wave. It means it is along z-axis, right? So direction of electric field is along z-axis. So you can write Ez equal to sine of this one, sine 0.5 into 10 to the power 3x plus 1.5 into 10 to the power 11 t. In this way, you solve this numerical. Hope you understood. It's very simple. There are two parts. Easily you compare standard equation with the given equation. You can find wavelength, angular frequency, everything. And then also you have to find expression for electric field. And direction of electric field is what? Along z-axis, that is perpendicular to direction of both magnetic field and direction of propagation of wave. Hope you understood. Please take a screenshot of this one. Then we'll move to the last topic, that is electromagnetic spectrum. Now, last topic of this chapter is electromagnetic spectrum. You know that there is a wide range of electromagnetic waves on the basis of their wavelength and frequency. So, the orderly distribution of electromagnetic waves in accordance with their wavelength and frequency into distinct groups, this is called electromagnetic spectrum. So, on the basis of their increasing wavelength and decreasing frequency or energy, First one is gamma ray, second one is X-ray, third one ultraviolet ray, fourth one visible ray, fifth one infrared ray, sixth one microwaves, and seventh one radio waves. These electromagnetic waves I have written in the order of increasing wavelength, in this order, wavelength in increasing or decreasing frequency or energy. It means frequency is in this order, nu or E, right? It means gamma rays has least wavelength and radio waves have largest wavelength. In the same way, gamma rays has highest energy and radio waves has least energy. Why? Wavelength and this energy or frequency reciprocal to each other. You know, E equal to H nu, or E equal to H nu is what? C by lambda. So energy is inversely proportional to wavelength and energy is directly proportional to frequency. That's why if it has larger frequency, it means it has least wavelength. So you must remember these electromagnetic waves in sequence in the order of increasing wavelength and decreasing energy. Okay, after this I will discuss in one table their uses, production, properties, wavelength range of all these electromagnetic waves. Please take a screenshot of this one first. Now this is a table of various regions of electromagnetic spectrum starting from gamma rays and ending with radio waves. These are arranged in the order of what? Increasing wavelength and decreasing frequency or energy. First one is gamma rays. Gamma rays wavelength range is less than 10 to the power minus 3 nanometer. You must revise these things, right? Its production, how gamma rays is produced. So it is produced by the radioactive decay of nucleus, and its properties and uses. Due to their high energy, it is used in radiotherapy to destroy cancer cells. It is used to preserve food stuffs and also in initiating nuclear reactions. These are its uses and properties, right? Second one is gamma rays. Its wavelength range in 1 nanometer to 10 to the power minus 3 meter. It is produced by X-ray tubes or inner electrons, and its use is, it is used in medical diagnosis and it is also used in study of crystal structure, right? Next, number 3, ultraviolet ray. Its wavelength range is 400 nanometer to 1 nanometer. It is produced by inner shell electron in atoms moving from one energy level to a lower energy level. It is used in eye surgery. Ultraviolet lamp is used to kill germs in water purifiers, and it is also used in food preservation. These are different uses. You must revise these uses, right? Next, fourth one is visible light. Its wavelength range is 700 nanometer to 400 nanometer. It is produced by electrons in atoms emit light when they move from one energy level to a lower energy level. Any electrons jumps from high energy level to lower energy level, it emits radiations, right? That is in the range of visible light. It provides, what is used? It provides information of the world around us. With the help of visible light only, we get the full information of the world around us. Also, it is used to initiate certain chemical reactions, right? You have to just revise these things, okay? Nothing is there. Next is infrared rays. Its wavelength range is 1 nanometer to 700 nanometer. It is produced by vibration of atoms and molecules, and it is infrared ray is used in greenhouse effect, greenhouse to keep plant warm, and in remote controls of TV sets. These are its uses. Next, sixth one is microwaves. Its wavelength range is from 1 meter to 1 millimeter. It is produced by magnetron valve, right, or valve tube. It is used in radar system, radar communication, in a microwave oven. It's very simple. Last one, radio waves. It has greater wavelength, greater than 0.1 meter. It has the highest wavelength and lowest frequency or energy. It is produced by rapid acceleration and deceleration of electrons in areas or antenna, you can say. It is used in, due to its highest wavelength, large wavelength, it is used in radio and TV communication system. It is used in radio astronomy. So these are about different electromagnetic spectrum range starting from gamma rays, ending with radio waves. You must revise all the names of these electromagnetic spectrum serial wise, then their wavelength range, production and properties and uses. Okay, hope you understood this one. Generally 1 or 2 marks question comes from these parts. What is the use of X-rays, how visible light is produced, what is the range of this microwave, what are its uses. So in 1 or 2 marks question, this topic is very important, electromagnetic spectrum. Okay, hope you understood. Please take a screenshot of this one first. So with this, I am going to end the class. Hope you liked this one-shot series of class 12th physics. Please like, share and subscribe my channel. Okay students, keep revising and stay tuned with this channel. Thank you.